Hey guys, welcome back to the Vintage Television Alignment Tutorial Series. How about we put into practice some of what I talked about in the previous two installments? And that would be choosing some test equipment and then performing a staggered tuned video IF alignment. I have the perfect set for it. It is a late 40s, I believe 1949 Admiral television. I highly recommend the late 40s Admirals for someone beginning to work on vintage TVs. It's a very straightforward, no-nonsense, robust design. And it uses that staggered tuned IF I talked about in the theory video. And that's where I got the frequencies from in my little chart that I threw up. So let's do a few things. One, review the set itself and identify some of the key components. Two, track down some alignment instructions. And three, see what equipment we're going to need. First off, you're going to want to accurately identify your make, model, chassis, and chassis production run if applicable, and locate specific service info for it. Do not try to guess or blindly go in and start tweaking coils and slugs and trimmer caps. It'll end in tears. You won't get the results you want. And there's no reason for it. Every set you're ever likely to encounter is well documented in Riders, Sam's Photo Fact, etc. If you can't find a copy, Sam's Photo Fact is still in business. You can still order them from their website or ask in the various online user groups and forums. Somebody will be able to help you out, I'm sure. Now let's identify the three key areas where we will be making adjustments. That will be the tuner or our front end, the video IF, and the sound IF and FM detector. The tuner is generally pretty straightforward. It's going to be where your big channel knob clunker is attached to. But in some sets it's not quite so obvious, like the porthole sets. It's a huge contraption way at the back of the chassis. Stromberg Carlson I worked on recently has variable slugs, and it's located up here, and there's dial string going way down to the tuner. If you're not sure, find your antenna terminals, trace out the twin lead and see where it connects. Wherever it terminates, that's going to be your front end, your tuner. So in this case, this is our tuner right here. Newer sets will typically have two tubes. Older sets might have three or more, but they're all going to have the same functionality. An RF amp, usually the tube closest to the twin lead coming in, a local oscillator, a mixer. This is the most sensitive, complex thing in a TV. Do not mess with this unless you absolutely have to, unless you know that there's something wrong with it. The upper channels, we're talking about hundreds of megahertz. The higher the frequency, the more sensitive the components are, the smaller they're going to be, and the more susceptible they are to getting out of alignment. Sometimes it'll just be a little kink in a wire, or the spacing between windings on a coil. Back in the day, in fact, you would typically, if there was something wrong with your tuner, you would send it to a dedicated tuner servicing place, and might have a trade-in policy for the tuner, where they would have technicians with the skill, the knowledge, the equipment to accurately set these up. So we're going to leave that for last. We're going to focus on the video IF in this installment, and that would be this section. Typically that's going to be where you're going to have your most tubes, your most adjustments. So in this case we have first, second, third video IF amps, and then a detector underneath the shield. These things poking up, these threaded brass shafts with the little slot on the end, this is what we are going to be adjusting. Notice in the tuner they look a little bit different. These are variable capacitors. These are variable inductors. At the end of these brass shafts there'll be a powdered iron slug. And we're going to be, when you adjust this, it moves the slug in and out of a coil. This is the sound IF. Usually you can tell it because it's going to be larger. It's a lower frequency IF. And the largest one will typically be your ratio detector, assuming your set uses a ratio detector. There's more than one way to detect FM. But in this case, that's what this big guy is. And there's a tube hiding behind. So we have 2 stages of sound IF. And then that is our ratio detector tube at the very end. Now there are 2 very distinct ways to do sound and video. This is a split carrier set, meaning the output of the tuner goes down 2 paths. The output of the tuner splits off and the video is amplified on its own, and as a path to the audio, and it's amplified on its own. Newer sets, for sure, and some earlier sets combine the 2 IFs, in which case you wouldn't have these 2 stages of sound IF. It would pick off the sound actually right before or after the video amp. And the sound in the video would get amplified through one set of tubes. There are pros and cons to the 2 designs. The biggest pro of having them separate is you can optimize each circuit for its respective role. The video is wide bandwidth AM, and the sound is a much narrower bandwidth frequency modulation. However, the 2 can get misaligned, in which case when you go to your fine tuning you can get a good picture with bad sound or a good sound with bad picture. It's one of the most common reasons why you might want to try aligning your early TV, is to get it so you get a good picture and sound at the same time, at the same position on the fine tuning. Another reason is they tinkered with the relative strength of the video versus the sound carrier over time. I think initially the sound carrier was much stronger than it was later on, and having them separate allows you to have different gain in the 2 sections. And of course the biggest pro to having them in one IF is, well, fewer tubes, and you always have the sound and the video fine-tuned at the same spot. But we're going to do a split one first. So we have 3 distinct things we're going to be doing. In this video we're going to focus on the video IF. I'll do a separate video on doing the sound IF, and a separate one on the tuner. Now let's look at the actual alignment instructions. Admiral was a popular brand. It was well published in both their original factory service info, Riders, Sam's Photo Fact, and Wallace Telliade, which is what I have here. I pulled that out because it's the largest form factor, and basically the entire procedure for all the steps is on one big sheet. Here is the Riders, and notice it looks exactly the same. In fact, both of these are just reprints of the original factory service info. Now sometimes, in particular with RCA and Philco, the manufacturer also made a line of test equipment, in which case their alignment instructions might be very specific to their line of test equipment. It might go so far as to say, take your RCA oscilloscope or RF generator model, blah, 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 and hook this up to this with the provided cable. Well, if you don't have that piece of equipment, it's up to you to interpret the instruction and modify them as needed for your equipment. In that regard, I recommend the Sam's Photo Fact, because they tended to be generic. They were not brand specific with their test equipment. They would just say, hook up your signal generator, hook up your oscilloscope. They wouldn't say that's a very specific model. Let's go with the Wallace Telliade because it's the easiest to read. I'll zoom in on it a bit, and let's start going through the sections. Typically there will be a block at the top above the individual steps. This is crucial. This gives us an overview of what we're going to be doing and what type of connections we need to make and what equipment we might need. Starts right off with connect a 4.5 volt battery. That is to fix the AGC. AGC, automatic gain control. That is a variable voltage generated by the receiver itself to adjust the gain of the IF to maintain a consistent output level. So when your signal strength varies coming into your antenna, if the signal strength drops off, it boosts the gain. If the signal strength coming in goes up, it lowers the gain. That will fight us when we are going to be feeding in our own signal. We don't want the amplifier modifying itself, modifying its own characteristics. So we want to disable that. We do that by attaching a fixed DC voltage to the AGC bus. Now they say a battery. By all means you can do that. I've certainly done it before many times. Rig up some AA batteries. It's not much current draw. They'll last you a long time. And connect it where they say. Or use a variable DC power supply, ideally floating, because you may have a hot chassis set, or maybe it's some other voltage and you don't want to short anything out. So we'll get into what I'm going to use in a moment, but that's what that is referring to. Allow 15 minutes for receiver and test equipment to warm up. Absolutely. Leave your set running for at least 15 minutes if you're going to use vintage tube-based test equipment. Get it all warmed up, tuned up, calibrated, and so on before you continue. Now the next 2 points are not so applicable today because we don't typically have any analog broadcasts left. But what they're telling you to do is disconnect an antenna and go to a channel that's not used, so you won't be receiving a signal that would throw off your alignment. We are going to be providing a signal. We don't want to be picking up any external signals. If you happen to have an antenna hooked up, or a converter box, a Roku, something like that, disconnect everything from the antenna terminals. Next up is something very specific to this model. And that's why I say you've got to get the alignment instructions for your chassis. This instructs you to create your own little RC filter. 10K resistor and a 330 picofarad capacitor. I rigged this one up years ago and I started doing alignments. I've done a lot of Admiral, so I keep that handy. And you are going to connect that as indicated down here. We'll get more into that later, but just if you're going to do this chassis, be prepared to have these 2 values ready to go. Now they say for steps 1 through 6, connect a signal generator high side to tube shield of 6J6 oscillator mixer tube. Be sure to insulate tube shield from chassis. So, we know we're going to need a DC power supply. Now we know we're going to need a signal generator, an RF generator. They're synonymous. Sometimes they say signal generator, sometimes they say RF generator. It's the same thing. Something that can generate frequencies accurately, that you have good output that you have good control in the output level of. Now, what are they talking about with this tube shield? Well, we need to feed a signal into the set. The RF front end, the first stage of the IF, this stuff is very, very sensitive. We have 3 stages of amplification. That's a lot of gain. We're going to be feeding in a very low-level signal. And we don't want to disturb the circuitry by connecting alligator clips, having leads hanging out all over the place, altering the grid bias unintentionally. So a common way to feed your signal in is to take the tube shield, pop it off of your local oscillator mixer tube, insulate it, throw some tape around the bottom lip, slide it back over the tube, and clip the high side of your your signal generator to the shield, and clip the ground to the chassis. This will capacitively couple the signal into the tube, into that very high impedance, high gain input, and that's what you're going to use for all these steps. You don't inject it. You might be thinking, oh, we'll inject it on the grid of the first stage, the grid of the second stage, the grid of the third stage. No, it's stagger tuned. We want to get the overall response of the whole system. We're going to be injecting it as indicated on the tuner, and we're going to leave it set up like that for all these steps, or at least steps, what do they say, 1 through 6. Sorry, 1 through 8. Moving on, set the contrast control at the center of its rotation. The contrast control in this model controls the gain, so it's important to put it in one position and leave it there for the entire duration. Now use VTVM. Okay, now that's another piece of the puzzle. Vacuum tube voltmeter. That is going to be our output level indicator. So we're not talking, notice there's nothing about a sweep generator or an oscilloscope or anything else fancy. No, all we're doing, we need a battery or DC power supply. We need an RF generator and a meter of some sort. Now I'm going to demonstrate several ways to do an RF generator and several ways to do an output meter. Yes, I will get out of VTVM, but I also want to show you that you can do it with a digital multimeter and with an oscilloscope. And notice they say on lowest scale 3 volts. Some VTVMs will definitely have a lower scale than 3 volts. But notice we don't need a detector probe or any kind of special demodulator probe. We're going to use the set itself and its detector and its video amp. So we're going to have a pretty strong signal coming out of it, and it's already been detected and all that stuff. We just need to add this so we don't load down the set. This 10K resistor will help decouple where we're going to attach it. In other words, when they say decouple, they mean don't perturb, don't affect the circuit you're reading a signal out of. This acts as a bit of an isolation, 10,000 ohms. And the 3300 is a filter. So it's a low-pass filter. And that's what we're going to connect our meter to. And notice I say it must have a frequency response of 4.5 megacycles. That's for the sound IF. For the video IF, it doesn't matter. For the sound, it will. And that's it. That's all the equipment we need. A battery, an RF generator, a meter. Well, let's take a look at the equipment I have out here and pick out some stuff we can use. Well, one thing you're going to need are what are sometimes called twiddle sticks. We need something to make the adjustments with. Ideally, you don't want to use a metal screwdriver or a metal tool because that can affect the capacitance or inductance of the circuit you're working on. So they're commonly made out of nylon or fiberglass. Now in this particular set we have these brass threaded shafts that are slotted on the end. This is the kind of tool you want. A plastic tube with a metal blade in the end. Yes, it has some metal, but it's only a small bit at the end and it's nowhere near your hand when you're making the adjustment, so it doesn't really affect things. And you simply slide it over the end and wiggle it around until you feel that blade lock into the brass shaft, and then you make this adjustment while looking at your meter. I will use this HP 6228B dual power supply for the bias. Again, 3 AAA batteries will do just fine. I happen to have this out, so that's what I'm going to use. I could plug this set right into the wall. It has a power transformer. It's a cold chassis. However, I like to have it hooked up to some type of current limiting device when I'm working on any set, so I can see how much current it's drawing and see if it's in the normal range, and also provide protection in case something shorts out and the current draw goes way up. A dim bulb tester would also accomplish the same thing. Meter. So I'll do it with an oscilloscope. I'll do it with a Fluke 27, but I will also pull out an RCA VTVM. For the RF generator, I'm lucky enough to have an 8657 HP, so I'll be using that, but I will also use some more, some smaller, simpler RF generators. You don't need anything this fancy by any means. One of my goals in this series is to keep the segments to a manageable length, so I'm going to break off here, and that allows us to have a dedicated video just on doing the actual video alignment. Between now and then, I'll get everything hooked up, make sure all the equipment is working properly, and then I want to try to do 3 different chassis to illustrate different IF frequencies in the intercarrier versus split carrier type IF design. So we're going to do this Admiral for sure, And then I expect I'll do a Motorola TS4 used in the VT71 and a Predicta chassis to round things out. If you have any questions, thoughts, suggestions, please leave a comment. And as always, thanks for watching.